Welcome to the Space Station Flight Control Room. We have joining us remotely from the Ames Research Center, Mark Murbach, who is the principal investigator for one of the experiments that went up to the space station on board the Cygnus. It's a satellite technology demonstration project, and he's going to tell us a little bit more about that. So I think you are the principal investigator for TechEdSat 4. What exactly is the investigation?
It's a multi-purpose project, really. At the first order is that we're trying to develop some technologies and the thermophysics of bringing samples back from the space station. And in particular, one of our end goals is to bring back something about this size, if you can see it. This beautiful sculpture, actually. It's a real proto-flight object, back from the ISS, and it would carry small samples that we would thermally control and be able to bring on a on-demand kind of process. So part of that larger effort is called Small Payload Quick Return, or SPQR, which is a historical acronym also.
So the idea is to be able to send small samples from the space station back down to Earth?
That's correct.
Okay, why would we need to do that?
The space station has become one of our important field centers. The field center, NASA has numerous field centers. This one now is in orbit, along with our international collaborators. And so we've solved the up mass problem. We take a lot of cargo up, but there's a lot of experiments that we would like to be able to get down from the space station on a on-demand or a more frequent opportunity. We are very, very fond of our space station and the crew, obviously, so we had to come up with a safe means of doing this. So when you typically deorbit something from orbit, you typically use a small rocket to do that. However, we certainly would not put a small rocket inside the space station and have it processed because of the obvious safety implications. So we had to rub our chins a little bit, and so the idea was to come up with a drag device to do that. And it's not obvious how we might do that. And it turns out that even at that altitude, 350 to 400 kilometers, there's a very tenuous atmosphere. And so if you construct a drag device such that for every kilogram you have a square meter of drag area, you can actually deorbit something in a few days. So we started to study that and then ask, okay, how do you do this? How do you practice? How do you do this? So that was part of the genesis of the TechEdSats, building small CubeSat objects that actually eventually build to a larger capability, and at the same time doing some very interesting thermophysics.
Okay.
So this is a sample, this is a sandwich of our exobrake device. The exobrake is the substitute rocket, the drag device that will bring things back from orbit, eventually on demand. And so this is one of numerous materials, but it's a sandwich object. You can see it's quite pliable. We can fold it, etc. And it's subject to high temperatures also. And so this is what we're experimenting with. This is the fabric of the exobrake that we have on TechEdSat 3 and 4. So basically we started with a CubeSat that also has wonderful, not only technological, but also educational aspects to it that I'm very excited about. And eventually we can evolve this into what we call a 3-unit or 3-liter satellite, which is this size. So our TechEdSat 3, 4, and 5, for example, would be made of this blank. And so we also experimented ways of making these cheaper. This is an extrusion. So we water jet it, and we build it up in a cartridge. We put the exobrake on one side, and it's a lot of fun. And so I work with a group of semi-gray beards, as I call myself, and my team, and also a lot of graduate interns from local and distant universities. So it's also, the educational aspect is also what makes it a lot of fun. So this is really a skunkworks. We do rapid proto-flight. Now, in a very safe manner, and we test the heck out of these things, but the whole process is very interesting.
It sounds like it. So how exactly, now that it's at the space station, what happens? How do you test it?
So the sequence, or as we call it, CONOPS, the concept of operations, is as follows. So once our device jettisons from the space station, and I should have mentioned, this is also very exciting, working with our colleagues at NanoRacks, a local Texas firm, we're now able to actually eject 48 of these things, or its equivalent, per airlock cycle, which is great, okay? And it turns out that we are launching a bunch of these also. So when it comes to our turn, we get launched from the ISS. It gets processed through the GEM airlock, our colleagues from JAXA, and then what happens is that this gets very carefully launched in a particular orientation and direction because we don't want to hit the solar panels on our highly esteemed dear space station, right? So this has to be pointed properly. And then basically the onboard timer kicks on. It counts on its fingers to 30 minutes, and then the communication systems turn on, okay? Then we begin to listen for that, and then for this particular experiment, we'll wait for several orbits and we'll send an uplink command via email. And the command will be received, and at that point the exobrake will be deployed, and it will stop tumbling, it will settle in orientation, and it will begin its deorbit in the next several weeks in this case.
And then are you able to retrieve it on the ground?
Not yet.
Okay.
So we would like to do that eventually. We're taking small incremental steps to do that to make sure that our techniques are evolving. So TechEdSat 5, the number 5 that's coming up, for example, will be the same size, but this will again have more advanced communication and control, and we'll have a device that actually we can expand and contract a little bit so that actually we can steer this through the atmosphere, targeting a particular location at the von Karman altitude, or about 100 kilometers, right at the very top of the atmosphere.
Well, it sounds like a really interesting project to be working on. We will be watching out for it to get started here on the space station for the next round. When about, I think, did you say a couple weeks from now, or?
We were listening in our teleconference today, and it depends on the scheduling. So there's a lot of scheduling that goes on with the space station, of course, and so it probably looks like maybe the end of August when the first batch of these things will first come out.
Okay, we'll definitely watch for that.
So,
thanks so much for joining us.
And we will too. Thank you, Brandy. I sure appreciate the invitation.
We appreciate you talking to us. Again, this was Mark Murbach, who is the principal investigator for the TechEdSat 4 on board the space station, just arrived on the Cygnus cargo vehicle. Thanks so much.